In previous video, we have discussed about what is the need of operating system. Now we are discussing about a module of operating system, which is called file system management module. OS consists of many modules. One of which is file system management module. It is managing files on secondary storage devices. So, how file system is managing device on operating system? So, by seeing this diagram, now can we say that give me the contents of file F1 from secondary storage device? So we cannot say, because device cannot understand file. Device understands only data. Data is stored in terms of bits, bytes or sectors. So there is a gap between what user wants and what actually is possible. This gap is bridged by file system management module, and file system management module converts logical view into physical view and then physical view into logical view. How file system stores information in tables? Which file is located where on the disk? So this is the table which having attribute file name and address of hard disk, and the address of hard disk is surface number, track number, sector number, that we call it 3D address. So to store address like this, lot of space is required, lot of space is consumed. Also to deal with 3 parameter quantity is cumbersome. So how to resolve this problem? If I do numbering in a manner such that there is no duplicacy, surface number 0, track number 0, sector number 1 to 1, surface number 0, track number 1, m plus 1, sector number m plus 1. So for this, instead of using 3D address, we store it into 1D address. So physical block and sector blocks are same. In 3D entity we say sector, and in 1D entity we say block. Now to save space, we will use 1D entity. For example, there is another table having attribute file and block number. So file F1 saved on block number 1 and 2. This scheme saves 1/3 of space, but there is a problem. Device controller does not understand block. It understands only sector. For giving instruction to DC, file system management module has to convert again 1D address into 3D address. Then, what's the advantage of 1D address? At all other layers, 1D address can be used. Only at the lowest level, 1D address has to be converted into 3D address. In case of index allocation, whenever the blocks are allocated one by one, and if the size required by a file is large, then all time one block is allocated and takes more time, which increases overhead. And if we increase block size, the space and time overhead will be increased in case of large files. But in case of a small file, the space will get wasted. So the minimum one block is to be allocated to any file. So there are some questions on this. Suppose it is known that file size are going to be very large, then what should I do? And what should OS do? So the answer is increase the block or sector size. Now suppose one sector is equal to 4K, that is one block is equal to 4K, and at minimum now one block has to be allocated. So in case of large file size, you increase the sector size, and vice versa for small size file, decrease the sector size. This is the one solution, but normally file system does not perform this solution. So there is another option, that is of logical block. Sector size is kept standard. One logical block is equal to n into physical block. Then the unit of allocation is now one logical block. Earlier it is one physical block. If n equals to 2, then when we are allocating one logical block, that is, we are allocating two physical blocks, so that you reduce your space requirement to 1 by 2. If n equals to 4, you reduce your space requirement to 1 by 4. One more thing is there, and another question. Suppose I have a fresh hard disk and I have a file which I want to store on hard disk. can I will be able to store on fresh hard disk? No, because on fresh hard disk sectors are not there. Suppose tracks are there, and even if sectors are not there, what is the problem? Why we can't store on fresh hard disk? Why cannot I say store the file on the track? Why I need sectors? Because the answer is DC cannot recognize less than sector. Sector is the minimum unit of allocation. If there is no sector on fresh hard disk, DC will immediately say that I cannot write on this hard disk as there is no sectors on fresh hard disk. It displays a message such as this disk is not usable. Operation of dividing the tracks into sectors is known as formatting. This division is not physical division. It is a logical division. Sector ID, that is the information, is written before every sector. Using sector ID, device controller can recognize it is on this sector. Because of this, size of formatted and unformatted disks are different. In formatted disks, some space is used for storing information, that is sector ID. In the instruction set of DC, there will also be an instruction format, the track. So it is controller who writes the information before every sector. DC will write the information in its own manner so that it can recognize it later. Hard disk, which is formatted using a particular device controller, if the hard disk is taken on a different machine with a different device controller, the hard disk is not usable or can't work. It has to be done formatted using the new device controller. A hard disk of one machine can be used on another machine provided the device controller on both the machines are same. It has nothing to do with the OS, that is independent of OS. So there are two types of formatting we have discussed, that is low level formatting or high level formatting. We can say that physical formatting or logical formatting. While formatting on every sector, a pre-decided data is written just for the reason that the formatted program writes some data on every sector and also reads back these data to see whether the hard disk is proper or not. Those sectors from which the same data is not written or read are known as bad sectors. Information about bad sector is stored and no file is allocated on bad sector. So recreation of file system, who creates those tables? What will be the size of the tables? Number of tables, who will decide? File system management module of OS will decide this. In high level formatting, you can say that recreation of file systems, who creates these tables, what will be the size of the tables, number of tables, who will decide? Then file system management module of OS is decided. Formatting would be done by controller. If file system is created under Linux, it cannot be used under Windows. In Linux, Unix, there is a command MCFS for creating the file system, and in Windows, this command is used for creating file system, that is format. So physical formatting and logical formatting. So it divides physical formatting divides text into sectors. It is OS independent but dependent upon DC. It is done by device controller. It can remove all the partitions. Data gets lost physically, performed only once in the entire lifetime of a hard disk. And in logical formatting, high level formatting, it recreates file system on hard disk. It is OS independent. It is done by file system module. It cannot remove tracks and sectors. Data gets lost logically once after physical format. Every time logical formatting is done. So this is complete information about how formatting is done, what is the importance of formatting, and how the file system manager module is working for formatting. Hope this will help you. Thank you.